So you should be able to see the unit circle here. So we'll talk a little bit about the unit circle and how it relates to sine and cosine. So you've just kind of started to be introduced to this thing, and right now it can seem a little overwhelming, but I'm going to go through all the pieces of it to kind of help you get started. I can't see who just joined, but if you just logged on, welcome, good to see you. But if you could turn off your microphone, that would be great. So our unit circle is going to highlight some of the popular angle measures that we will see when we're dealing with trigonometry. So down here, you'll have your 0-degree measure, but then also you'll notice as we get around the unit circle, this will also be your 360-degree spot. And then it also highlights the coordinate on the circle as an X and Y. So this coordinate right here has an X coordinate of 1 and a Y coordinate of 0. If we head up to the top, which is like the top of our Y-axis up here, this is another highlighted angle measure, 90 degrees. That has an X coordinate of 0 and a Y coordinate of 1. If we head down to the negative X coordinate, this will be 180 degrees. And that's going to have a X coordinate of -1 and a Y coordinate of 0. And I'm going to have to scroll down a little bit, and we'll head down to 270 degrees, which is going to have a X coordinate of 0 and a Y coordinate of -1. So those are some popular benchmarks on our coordinate plane: 90 degrees, 180 degrees, 270 degrees, and then all the way around 360 degrees. And then the corresponding coordinates that go around, that go along with those points. The extra blank spaces that you are seeing, these spaces right here, these are going to be what we fill in our radians. We are not to radians quite yet, so you can disregard those when you're filling out your unit circle. I just want you to practice your degrees and then your coordinates. That's it. The radians we will get to in a little bit, but for right now, just degrees and your coordinates, your X and your Y's. All right, now we'll head into looking at the other popular measures. We're going to start with the 45s. And we just practiced the 45, 45, 90 triangles. And I wanted you to start kind of thinking back to geometry and how those 45, 45, 90s worked, and then the rules that go along with how you can find legs and the hypotenuse. So this angle right here is going to be a 45-degree angle. And I should back up a step. We're always comparing our angles to the positive x-axis. So this is called your initial side right here. So we're always comparing to this positive x-axis. And for the 45, 45, 90, we are looking at what is the measure, this angle measure right in here. So that angle right there is 45 degrees. So we're always comparing it to that positive x-axis. So 45 degrees. Now we want to figure out, well, what are the coordinates of this point of this 45-degree angle coming out and hitting this unit circle? The X coordinate of that point would be the horizontal distance that I'm going to travel along this x-axis to get level with that point. So this is going to be the X coordinate of that point. The Y coordinate of that point is going to be this vertical distance that I would be traveling. That's going to be this Y coordinate. So if you look at what we're starting to form here, is we're starting to form a triangle that's got a 45-degree angle. And the 45 degrees is going to be this angle down in here. Well, if one of those angles is 45, you learn that, then that means this other angle is 45, and this angle right here is 90. So all we're dealing with is a 45, 45, 90 triangle. Now this 45, 45, 90 triangle, the only thing that we know about this triangle is this hypotenuse. And this hypotenuse, since it starts at the center of the circle and extends out to the outside of that arc on the circle, that is going to have a distance of 1 because we are talking about the unit circle. So unit circle means that all of the radii that go around the circle have a distance of 1. So this is the only thing that we would know about this triangle that we're drawing, is that it has a distance of 1 right here. So one thing that you were looking at is the rules for 45, 45, 90s. If you know the hypotenuse and you're trying to find the leg, you're going to take your hypotenuse times the square root of 2 over 2. That's going to give you your hypotenuse. So that was one of the rules that a lot of you developed when you did your class check yesterday, which was awesome. Also, you'd put that you would divide by the square root of 2. Either way, you're going to rationalize, and you'll end up getting, whenever you're dealing with a 45, 45, 90, to find the leg, you're going to take the hypotenuse of that 45, 45, 90 and times it by the square root of 2 over 2. Well, our hypotenuse in this case is going to be 1, so 1 times the square root of 2 over 2 is still the square root of 2 over 2. So what we just did there is we found that this x coordinate, this leg, is square root of 2 over 2. And this y coordinate is square root of 2 over 2. If those are the lengths of the legs, that's the x coordinate distance that it has to travel. That's the y coordinate distance that it has to travel. So that tells me that the coordinates of this point are square root of 2 over 2, and then square root of 2 over 2. So there's going to be our 2 coordinates for that 45-degree angle. So that's going to be the position of this point on the coordinate plane, is it's got an x coordinate of square root of 2 over 2, which is the length of this leg, and a y coordinate, which is square root of 2 over 2. Now, another thing that you learned back in geometry when you were learning that, or even if you're in geometry this year, is Sohcahtoa. And we just need the so and the ka when we're talking about sine and cosine. Your angle that you're talking about is right in here, and I'm going to call it theta. That's what we use to represent angles. If this is my angle right here, y would be considered my opposite side, which relates to sine. My x is my adjacent side, which relates to my cosine. Sorry, I'm getting a little sloppy with my writing, but that's going to be then my cosine. So another thing in our class check yesterday was the x coordinate represents the cosine. The y coordinate is going to represent your sine. So the cosine of 45 degrees is square root of 2 over 2, and the sine of 45 degrees is going to be the square root of 2 over 2. So that's another thing that we talked about back in geometry. Now, to start completing the rest of the unit circle, we're going to use reflections. So this 45-degree angle, if I connect over to this point, just going straight across, that's just a reflection across my y-axis. And all that's going to happen is when I go from this point in the first quadrant over here, for this point in the second quadrant, is my x coordinate is going to change to its opposite. So now I'm going to the left on my x-axis, so that x coordinate is going to change to its opposite. We're still dealing with the same type of triangle, 45, 45, 90. So the square root of 2 over 2, those lengths will still stay the same. It's just that we're moving into a different quadrant where those coordinates are changing to their opposites. Now this position angle-wise is going to be 135 degrees, so it's 45 degrees more than 90. So 90 was up here. And its x-coordinate is negative square root of 2 over 2. And the y-coordinate is still square root of 2 over 2. So it's the same two values as the original position over here, except now we're in the second quadrant. So in the second quadrant, your x's are negative, your y's are positive. Then we'll head down to the third quadrant, which I'm just going to zoom out for a second. So we'll head down to here. This point down here, I'll zoom back in. This point down here is a reflection over the x-axis. So now we've got, down in the third quadrant, our angle measure is going to be 45 degrees more than 180, which is 225. And our our x-coordinate is going to be the negative square root of 2 over 2. And our y-coordinate is going to be square root of 2 over 2. Negative square root of 2 over 2, because now I'm down to the third quadrant. In the third quadrant, both your x and your y are going to be negative. And then we head back to the fourth quadrant. So this point right here has a coordinate of positive square root of 2 over 2. And the y-coordinate is negative square root of 2 over 2. So once we know that first quadrant, we can reflect those points all the way around the coordinate plane, and we start to see the same coordinates, just depending on which quadrant you're in, first, second, third, or fourth, you'll see those positives and negatives. So this method that I'm using is called the Bowtie method. So if you connect all of your angles, and it's kind of in there, you can kind of see a bow tie kind of forming in there, but that is one method that you can use to start creating your own unit circle. So I'm going to save this, and then we'll head and look at the second type, which are the 30, 60, 90s. Okay. And we'll get back to the new one. All right, so back to our unit circle again. We're now going to take a look at the next type of angles that we're going to see are the 30s, 60s, and 90s. So that would be this angle right here, 30 degrees. And then this angle right here, 60 degrees. So we're looking at this point now right here. If I connect a horizontal leg along the x-axis, I connect a vertical leg along the y-axis, I'm going to start to again form a right triangle right here. This is my 30-degree angle down here. That's going to make this my y coordinate. This is going to be my x coordinate. And your x actually is going to represent the long leg. And your y is going to represent the short. So we're going to use the rules of 30, 60, 90 that you started to find when we were practicing our special right triangles. Now remember again, your radius in your unit circle is always going to be 1. So that's going to be a 1 right there. So a lot of you started to talk about the rules to find first the short leg. Short leg's a little easier to find. To find the short, you're going to take your hypotenuse and divide it by 2. So whatever your short leg is, it's going to be your hypotenuse divided by 2. Well, here our hypotenuse is 1, so we're going to take 1 divided by 2, which is simply just 1/2. So a lot of you put that as your rule in your class check. Take your hypotenuse divided by 2. That's going to be your short leg. Next was your long leg. And your long leg you can also find using your hypotenuse. Your long is your hypotenuse times the square root of 3 over 2. So to find your hypotenuse, I can take, to find my long leg, I'm going to take my hypotenuse times the square root of 3 over 2, which hypotenuse again is 1. So that means my long leg is the square root of 3 over 2. There's going to be my long leg. So there's going to actually be my x coordinate, square root of 3 over 2. So I'm using those rules of the special right triangles and knowing that my hypotenuse of these angles is always going to be 1. So I'm using 1 as my hypotenuse when I'm using these rules, and then I can start to develop the x coordinate, which is square root of 3 over 2, and the y coordinate, which is square root of 3 over 2. And I'm going to switch color for the 60. So 60 will change to purple, so it's just a little bit different. So now on the x-axis, to get to 60 degrees, x is going to represent my short leg. Y is going to represent my long leg. So my short leg in this 30, 60, 90, my hypotenuse is still 1. So my short leg is going to be 1/2. That's going to be my x coordinate. And my long leg is going to be square root of 3 over 2, which is going to now be my y coordinate. And just like before, your sine is your y coordinates. So anytime we're looking for a sine, we use the y coordinate because that's your opposite leg of the angle. So Sohcahtoa, I'm using Sohcahtoa to determine that. And x is going to be your cosine because x is always the adjacent leg to your angle. Now we'll use the Bowtie method to fill in the rest. So it's going to be the same two coordinates, just reflected around the coordinate plane. So square root of 3 over 2, we reflect it over. And it's going to get a little messy, so I don't know if I'm going to draw this in every time, but now we just have the x coordinate's going to be negative because we're in that second quadrant. So negative square root of 3 over 2, and my y coordinate is still going to be positive. We head down to the third quadrant. Both of them are negative. So negative square root of 3 over 2. 3's are really hard to write with my mouse, so sorry about that. And then negative 1/2. And we head over to the whoops, I put that in the wrong spot. I'm sorry. Let me slow down a little bit. So I should maybe draw this to help me out. There we go. And since we're in the third quadrant, we're going to go negative square root of 3 over 2 and negative 1/2. So in all of these cases, my short leg is going to be that y coordinate of this triangle that I'm forming. And heading into now the fourth quadrant, we've got positive x and negative y. So there's your coordinates. Lastly, we'll head into the purple. So these 60 degrees, head over to here. The coordinate is going to be x is negative 1/2. Y is positive square root of 3 over 2. And I forgot to on my blue, but this is going to be 30 degrees more than 90. So this is going to be my 120 degree. So on the blue one, you can do that on your own. Heading down to this point right here. Both are negative, so it's going to be negative 1/2 is my x, which is my cosine. And then y, my sine, is negative 3 root of 3 over 2. Heading over to my last, x is positive, so it's going to be positive 1/2 over negative square root of 3 over 2. So there's your unit circle all filled in. So my method that I use is I only find the first quadrant. Once you know this first quadrant, then you can use those reflections to find all your other coordinates. So you're just going to identify your x and y coordinates of those 30, 45, and 60 degree angles. Once you know those three, then you can start to use your properties of the coordinate plane with positives and negatives, and you can start to find the rest of those missing coordinates. So we'll save this one as 30, 60, 90. And if you request me to send this to you, I have all these saved, so I can for sure send you pictures of these if you would like to take a look at those. All right.